Hey, Algebra 3 class. This section is going to be about complex fractions. So far, we've been studying things about rational expressions. And before we get to rational equations, which is the next section after this one, we need to take a look at something called complex fractions. So let's get started. So here we have what a complex fraction is. It says a complex fraction is one that has a fraction in its numerator or its denominator or in both numerator and denominator. So I have some examples down here. Here we have a fraction right here in the numerator, and then we have a denominator here. And then we have a fraction. It can look like this, a complex fraction. A fraction, there's a one in the numerator, and then there's just a single thing in the denominator. But here we have a complex fraction that has a fraction in the numerator and in the denominator. Okay, so we have two numerators and two denominators. Let's take a look at an example. All right, before we look at our example, actually, we're going to look at this method, our first method here. Our first method deals with finding the LCD of all the denominators appearing in the complex fraction. So that's the first thing we do, is identify that LCD. And then the second step is multiply both numerator and denominator of the complex fraction by the LCD. And then once you're done multiplying, you just simplify further if possible. So there's 3 steps in this method. All right, so in this first method, I guess we call it the multiplying first method, what it said was identify the LCD. So I'm going to, on this one, the least common denominator of both of the denominators in this complex fraction are just going to be these two denominators multiplied together, because there's nothing in common with these two denominators. We're just going to list it as the LCD, and that is 4 times b cubed. Okay, now for this complex fraction, our next step in this to simplify it was multiply both numerator, so this up here, and denominator by the LCD. So I'm going to multiply by 4b cubed here and multiply this by 4b cubed. Now when I do that, it's like saying 4b cubed over 1, and same here, 4b cubed over 1. All right, I'm going to separate it out with the division symbol. Now, in this next step, we multiply this numerator to numerator and this denominator to this denominator. And when we do that, we actually have some cancellations that we can do, and that's what we want. We want our denominators to actually cancel out in each fraction. So b3 or b cubed and b cubed, they both cancel out. And so now multiply straight across. We have 12a times 4. So that gives us 48a. And now let's deal with this denominator. Now, just like the b cubes canceled out, our 4's here are going to cancel out. And then we're left with multiplying b squared to b cubed, which is b to the 5th. And that actually, we're done, because this thing does not simplify any further than that right there. So we're done with that one. Okay, let's do the same thing with this one. We're going to find the LCD. This right here is a factor in our denominator, because they're being subtracted or added together. These you can't take x as a factor and y as a factor separately. It's x minus y is the factor in the denominator, and then y is our factor in this denominator. So our LCD, again, we just multiply x minus y times y together to get our LCD. I'm going to write that over here. LCD of this one is y times x minus y. So again, multiply both numerator and denominator by your LCD. So this one I'm going to multiply by y times x minus y. And here again, and it's like saying over 1. If you want to draw that 1 in, you can. You don't have to. Multiply this denominator by y times x minus y. And I'm going to go ahead and put it over 1. Now start canceling things at this point. Multiply. So this factor cancels out this one. This one cancels out this one. Now multiply straight across in both numerator and denominators. So x, since this canceled out, that's 1 times 1. So we get nothing there except 1. And so we have x times y here over, and then x squared times this right here. So write it out as x squared, or sorry, squared times x minus y. Now, the next step is simplify any further if possible, and we can actually take another factor of x out of this right here. This is like saying x to the first, and it completely cancels out with one of the x values here. So we're left with to the first power in the denominator here, x to the first. So we can write this answer as y over x times x minus y. And we are done. You can, if you want, distribute this, but it's not necessary. You do not have to do that. You can keep it in your factored form. Right, next step, I'm going to show you, or the next slide, I'm going to show you another method. All right, so in this method, it says to add or subtract the fractions in both the numerator and denominator of the complex fraction to obtain a single fraction in both numerator and denominator. So what it's saying is if we have something like x plus 1 over 2 plus x plus 3 over 4, then that over x, then we need to combine these two fractions first as one fraction. And then we will end up, like we've done in the previous section, we should know how to add together these and get a common denominator and simplify this, what I've circled, in the numerator first. And then on this one right here, this is just a single x value. So we can also say it's like saying it's over 1. Once we simplify this, we say this is equal to this simplified times, and we invert this because this is our division symbol right here. So we are adding and dividing fractions in this method here. So just pay close attention to this method. It's a good one if it's necessary. Okay, so I have the same examples that I had previously, and I'm going to do it with this method that I just went through. There is nothing being added or subtracted in the numerator here or in the denominator, so there's nothing for us to combine. Same goes with this one. There's nothing for us to, there's no other fraction like saying this add together in this numerator. So what we do is go to the second step. We multiply this numerator by the reciprocal of this denominator because this is acting as our division symbol here. Okay, so this is equal to 12a over b cubed times the reciprocal of this, so flip this, and you get 4 over b squared. Now we just multiply straight across. So we get 48a over b cubed, and we're done. So sometimes this method works a lot better than the previous one, finding the LCD and then multiplying both numerator and denominator by it. Sometimes each method can be more work than the other depending on what kind of complex fraction you have. You just have to practice at it to figure out which method is best for you at that time. All right, so let's do the same thing. We have our numerator here, our denominator here, and we're going to multiply this numerator to the reciprocal of this denominator. Okay. So y times x squared. Now on this one, we just multiply straight across, but before we do, we can actually cancel out this factor of x with one of the factors of x here. So we're left with 1 here and x to the first here. Now multiply, we have 1 times y, just y, and then x minus y times x. So x times x minus y. And like I said previously, you can just leave this in its factored form. You don't have to distribute that x through. And we're done with this one. So like I said, sometimes this method works better. All right, so now I'm going to show you again the first method and compare it to the second one in a fraction that is complex and we're adding two fractions together, or sorry, subtracting two fractions together in the numerator, and we just have a single fraction in the denominator. So first method was multiply by the LCD. Let's figure out what the LCD is first. Okay, we got to look at each fraction. So here's one, here's another, here's another. We have three fractions here to make up this complex fraction. Here we have a factor of x squared. Okay, that covers the factor of x because there's an x inside of x squared. So we only have to state, we don't have to say x squared times x for our LCD. We just can say x squared. We always pick the highest multiple there, I guess is how you can put it. So x squared, we're not going to multiply to x. I'm going to list that as one of our factors in our LCD. And then we have this, which is not in either one of these factors. So say 6x times x squared, that's our LCD. Now multiply both numerator and denominator by your LCD. I'm going to come over here and say multiply by 6x squared. Okay. Now this thing distributes to both of these values inside what I just put the parentheses around. And then this will multiply straight to this one. All right, so I'm going to multiply, I'm going to just write it out. 6x squared times 5 over x squared. And again, 6x squared, because we're distributing, times 2 over x. I'm going to go ahead and multiply the 6x squared times the x squared over 6. Well, these are the same in the numerator and denominator, so they can cancel out. And now we just multiply straight across. X squared times x squared, that's x to the 4th. Now let's simplify this up here in the numerator. Well, 6x squared times 5 over x squared, our x squareds actually cancel out. And we are left with 6 times 5, which is 30. And then we have this right here, 6x squared times 2 over x. Again, this x cancels out with one of these x factors. And so we're left with 6x times 2, which is 12x. and then that is all over x to the 4th. And there, we're done with this one. Because there are no factors in this right here that we can cancel out in both numerator and denominator. All right, so let's try this again with our other method. Okay, so our other method said combine together fractions that are being added or subtracted first before we do the multiplying by the reciprocal. So first we have to use our skills from our last section and combine these together before we do anything. Okay, so remember this right here has a factor of x squared. This one has just a single factor of x. To get common denominators between these two, I need this one to have another factor of x. So multiply both numerator and denominator by x. So we get 5 over x squared minus 2x over x squared. That's all over x squared over 6. Now combine together these fractions. Since we have common denominators, we can do that. This is going to end up being 5 minus 2x over x squared, and then that's over x squared over 6. Now, the next step in this method, now that we've combined together our fraction over here, these two fractions over here, we need to multiply this numerator by the reciprocal of this denominator. So I'll multiply this times the reciprocal of this. So flip this around. Come down here and do that. So we're going to say 5 minus 2x over x squared times our 6 times, or divided by x squared. Now we multiply straight across. Make sure when you do this, we distribute that 6 to both of these. So we get 30 minus 12x over, and then these multiply, x squared times x squared, x to the 4th. And there we go. We are done. So depending on which method you like, you can go with either one. But for this particular one, I think the LCD one worked just a bit faster. There were less steps. I'm going to turn back so I can show you this. See, once we figured out what the LCD was and multiplied, we just multiplied this and we ended up with our answer. This right here, it took us a bit longer. We had to combine these two fractions first, add their numerators together, and then finally multiply the numerator by the reciprocal of the denominator, and then multiply. And then finally got our answer. So, like I said, sometimes you'll want to use one method, sometimes you'll want to use the other. All right, on this last example I have for you, just because I'm the teacher, I'm more skilled than you are, I am going to choose the method of finding the LCD first and multiplying everything by the LCD. Just because I know that is going to work out quicker than the other one. Because then we'd have to combine these fractions together by addition and then combine these fractions by subtraction, and that just, it's going to take a lot longer. So the LCD of this complex fraction, look at each of your denominators. So this has a factor of a minus 1. Here's a plus 1. Again, a plus 1, a minus 1. So those two factors just multiply together. So a minus 1 and a plus 1. Now, if you don't want to say, let's multiply all of this by the LCD and all of this by the LCD. You can look at these as individual fractions and just say, let's multiply this by the LCD, and then this, and then this. All four of these fractions multiply by the LCD. Okay, so that's what I'm going to do. If I were to multiply this LCD to just this right here, can you see how this would cancel out with this portion of the LCD? And what I would have left is a plus 1 times a plus 1. So that's what I'm going to write down for the first one. A plus 1 times a plus 1. And then again, multiply this right here by the LCD. The a plus 1s are going to cancel out, and I'm left with a minus 1 times a minus 1. And then that is all over. And it happens all over again. We have the a minus 1s cancel, and we have a plus 1 times a plus 1. Minus this time instead of plus. Again, the a plus 1s cancel, and we're left with a minus 1 times a minus 1. Now, there's just no easy way around this. We are going to have to FOIL all of this and all of this. Each one of these things that are being, each one of these factors that are being multiplied together, we have to FOIL it. And then, after FOILing it, we just need to combine our like terms, and we're done. So, let's go ahead and do that. A plus 1 times a plus 1, a squared plus 2a plus 1, then plus a minus 1 times a minus 1, we get a squared minus 2a plus 1. And then that's all over. Since we already figured out what a plus 1 times a plus 1 is, just write that down again. But this time we have a minus sign, and this minus sign is going to distribute to all of these three values. So I'm going to go ahead and do that and say minus a squared plus 2a minus 1. Now combine all of these like terms in both numerator and denominator. So we have a squared plus a squared, that's 2a squared. 2a minus 2a, that's 0. Then 1 plus 1, so we have 2. Let's do the same thing here. Have a squared minus a squared, that cancels out to be 0. Then 2a plus 2a, so that is 4a. And then we have a 1 minus 1. It cancels out to be 0. All right, so the last step in this actually is we can factor a 2 out of this. Let's go ahead and do that. I'm going to say 2 times a squared plus 1 all over 4a. And then this fraction right here, 2 over 4, that reduces to 1 over 2. So we have 1 times this, which is just what's in the parentheses, a squared plus 1 over 2a. And then we're done. That's it. So this is the method I would have chosen for this. This is the finding the LCD and multiplying the LCD to each one of these fractions in your complex fraction. So I'll see you all in class, and we'll work on all of this together. Goodbye, everybody.